Hi everyone, today I'm excited to share the progress of a falling sand game powered by neural nets. Let's dive into the evolution of this project and the fascinating challenges I've encountered along the way. My journey begins with an ambitious idea inspired by a paper about using stable diffusion to run Doom. Intrigued, I thought I might be able to do something similar but scaled down with my RTX 3090. After trying stable diffusion for myself, the results were interesting. While I'm sure you could coax something meaningful out of this approach, doing so with 24 gigs of VRAM proved to be quite the challenge. Undeterred, I decided to pivot and use a more tailored approach. Enter our first convolutional neural network model. Banch, wow, wow. This model uses convolutional layers with batch normalization. It takes in 7 channels, 1 for each element, and outputs predictions for the next state of each cell. This version showed great promise. It had a basic set of elements, sand, water, plant, wood, acid, and fire, and acted somewhat realistically. However, it did have its quirks. Liquids were a bit chunky, shall we say? With a working proof of concept, I decided to up the ante. Enter the improved sand model. This model introduces several improvements. Increased input channels to 14 as we added more element types. Used a larger initial kernel size of 5x5s to capture more context. Implemented a bottleneck architecture, expanding and then contracting the number of channels. The results, we hit a smooth 60 frames per second and saw improved interaction between elements. However, we faced some challenges with time-dependent phenomenon like fire fading over time. There's also this strange waterfall effect that's been happening where the bottom part of your drawings fall faster than the top part. Sometimes less is more, and our next iteration, Simple Sand Model, took that to heart. This only uses 3 convolutional layers, keeps a consistent hidden size throughout, removes batch normalization layers, but the big kicker is it only uses the training set data that has the highest movement. And wow, did that deliver. We're still getting our 60 frames per second, and we're seeing much improved behavior with temporal elements like fire. Fire now fades naturally over time, creating a much more realistic effect. Overall, this version feels much more natural and responsive, capturing the dynamic nature of our falling sand world, but we still have the waterfalling issue and some elements don't work right. Looking into the future, I'm excited to try out curriculum learning. The plan is to gather data for each element individually, then in pairs, and then finally all together. We'll also use 3 frames to try to give the model more time context. During training, we'll start with the simple scenarios and work our way up. It's a work in progress, but I have high hopes for this version. The most exciting takeaway for this journey is that we basically created an accelerator for a falling sand game. Traditional versions of the falling sand game tend to slow down the more elements and more interactions that are on screen. But the AI version doesn't have this drawback. You can have a full or empty screen with as many interactions as you want, and it'll run at the same frame rate. All the source code for each of these versions is available on my GitHub. Feel free to play with each versions or mess around with the model architecture. Thanks for watching. Bye.